I have a couple of curiosities rather than questions. The first is, you mentioned hydrogen as a potential flexibility asset. Do you mean hydrogen for exploiting the curtailment of renewables, or you mean something else?
For the curtailment of renewables and also as a flexibility providers, because PEM electrolyzer are flexible and they can work efficiently, not like the Alpine one under partial load, and so that it can go up and down with the frequency relation to have some frequency relays. So it can be like a controllable load to go up and down with the frequency. And so we have some sort of frequency response and spin and reserve to help with the stability and the control of the grid. But of course, after some time, when the production goes to a level that the consumption of electrolyzer is significant, that under the 25% with a related percent of them up and down, it can make the issue for the other, like it's much from technical point of view, it's much more effective, like the best systems, but unfortunately from the economic point of view, it's much more costly.
Okay. And the second question was about the blackout engineering. So which one of the technologies or strategies you described was missing and they are planning to implement?
Now I think they have dedicated over like 4 million euros for the best systems, and then for the best system, and this is one of the solutions, best system, so that now we have multiple services, so we have storage, we have a black start probability, and of course battery can almost support all of that ancillary services that we need, frequency response, fast response, even in a matter of milliseconds, because of course it has no moving parts and this stuff. And the second, after this, they enforced some synchronous power plants to stay in operation even if their production is not required, but as for this inertia and in production. So in case some imbalances happen, yeah, maybe we can go to some load shedding of some like the residential power until like this conventional power plants go up and down.
Keep thermal power plants on.
Yeah, but it's now it's like the state of Ireland stated that non-synchronous have a limit of 75%, and the 25%, and also they have dedicated like in the new emerging one, there is some service now explicitly defined in Ireland, which is called the synchronous inertial response. That is representative of the inertial service that we have. Like we have like 10 gigawatt of conventional power plants, but their production maybe it's 2 or 3 to the lowest, and they are pushing lower and lower the minimum technical, so that they can go up and down covering any imbalance. But of course now with the 15-minute one, because yeah, it was in the hourly one, it was difficult. But now under the 15-minute one, yeah, now the predictable is much lower, and for this and the wind power plants, even if this is not economic, but for the 15-minute one, we can have some like this as a backup. And for the 15-minute one, yeah, maybe they can slightly increase their like bid in the first 15-minute, decrease it in the second 15-minute. So now, yeah, the 15-minute one presents like a significant evolution towards have better and better like estimation and reduce imbalance to the lowest possible.
Just a brief question.
Yeah.
So when you mentioned that your differential equalizer are PM, what is the power size that you're thinking about? So what's the average power, total power of the application that you're thinking?
Yeah, actually, right now it is not on a wide basis, but it's expected like if like the situation goes with like close to 2035 with the phase out, now it's gonna expected like to increase more and more because
If it was not pure enough. So if you think of an equalizer, what would be the average rated power of the device that you're thinking?
means it goes to several megawatts.
So you need several megawatts equalizers that are going to be
For a single one, yeah, go to 7 megawatts. Like the proton exchange membrane, like the whole cell and this